Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. And now we are going to talk about the cotangent function. Now, in the previous video, we talked about tangent inverse. And you see that there is a relationship between these trig functions. So remember that when we differentiated sine inverse was given as square root of 1 minus x squared. And then when we did for cos inverse of x, it was just the minus of the sine inverse when we differentiate the sine inverse. So it means that the trick here is if I know this, then this becomes what? Bonus. The same thing for tangent and cotangent. So in the previous video, we saw that when we differentiate tan inverse of x, this is just equal to 1 over 1 plus x squared. So guess what? What will be when we differentiate this? Okay, let's see. When I differentiate this, it's just going to be the minus of this. So when you are learning, sometimes you need to make sure that you have, some way of keeping track of all the things that you are learning so that things become more easier for you, right? So when I differentiate cot inverse or the cotangent of x, this is just equal to minus 1 over 1 plus x squared. So what is the bonus here? For me, when I'm learning, sometimes I just learn this and then learn this. But I know that sine inverse is going with the cos inverse, and then the tangent is going with the cotangent. So if I know this positive, I just learn the positive ones, and then now the negative aspect goes for the ones that they are going together. So this is what we are going to get when we differentiate cot inverse of y or the cotangent inverse. Right. So now we know that when I differentiate the cotangent inverse of x, this is just minus of the tan inverse, 1 plus x squared. Let's prove that. So we have this. So it means that if y is equal to the cotangent inverse of x, then cotangent of y is equal to x. Let's go through the same process again. So differentiate both sides with respect to x, and then we are going to have something amazing. So the question is, when I differentiate cot of y or cotangent of y, what am I going to get? Okay, this is going to give us minus cosecant squared of y. So this is what you are going to get. And we need to multiply it by dy over dx because we need to use the change rule here. Great. And when I differentiate x, I got 1. So now it means that dy over dx is equal to minus 1 divided by the cosecant squared of y. And we will talk about the secant and cosecant in the next 2 videos very soon. Now, what is the trig identity for this? Now, we know that 1 plus cotangent squared of y is the same as the cosecant squared of y. Nice. So this is one of trig identities. So it means that we can replace this one by this. But we can also write cotangent squared of y as cotangent of y all squared, right? So we can write this one as minus 1 divided by 1 plus cotangent y all squared. So we just replace this, which is here, by this. Now, what is the cotangent of y? That is our x here. So this is just going to give us minus 1 divided by 1 plus x squared. You see, it's very nice. Now, this is very nice. This is beautiful, right? It's easy to go with this. All we just need to do is we practice. Maths is all about doing practice. You need to practice. If you don't practice it, you are not going to, get the formulas and understand the procedures behind, getting a particular formula. So now let's look at how to generalize this. So this one is going to be the same as the tangent inverse, but we are just going to use the minus aspect, then we are done. So this of u is going to be minus 1 divided by 1 plus u squared times u prime. So it's just the minus of this. So everything that we are going to do is like the previous video that we are going to do here. Right. So let's go through this examples. Then I'll give you some to also try. Don't forget to subscribe and don't forget to give us thumbs up in the comment sections and also give us a like. So let's look at this. Now I want to differentiate sine of x cotangent inverse of x. Nice. So now I see that here I have two functions, so I need to use the product rule. So I'm going to assign a to sine of x and b to cotangent inverse of x. So a prime, we know that when I differentiate sine, trig functions, we need to have cos of x. And then when I differentiate b prime, now we just learned from this that this one should be just minus 1 divided by 1 plus x squared. So this is what we are going to get from here. Nice. Now what can we do again? Okay, now let's see. We know the product rule. So the product rule, I have my a, b prime, plus now b and a prime. Here addition is commutative, so somebody can write this one as b a prime plus, a b prime. Anyway, it's right. With the product rule, it's flexible, other than the quotient rule. So now let's just use this one. So a times b prime is going to give us minus sine of x divided by 1 plus x squared, right? So I just multiply this one by this. If you are not seeing what I'm doing here, then this is basically this. So this is sine of x times minus 1 divided by, so let me put this one in parentheses, plus, now I have b times a prime, so cot inverse of x times cos of x. And when I simplify this, now this multiplies this, and I'm going to have minus sine of x divided by 1 plus x squared plus, okay, I can keep cos first and then cotangent inverse of x here. So this is what we are going to get. So the idea here is that anytime I'm doing differentiation and I know the rule and I know how to differentiate a specific function, it's more easy to enjoy derivatives. So that's basically the idea here. Now let's look at this one too. We want to differentiate y with respect to x. So y is equal to cos of x minus cot inverse of square root of x. So the good thing here is I know how to differentiate cos. I know how to differentiate cot inverse. So you see that it becomes so easy for us to do this. I know that when we differentiate cos, what do we get? Trig function. Right, you got it right. That is minus sine of x. Minus, now when I differentiate cot inverse, what am I going to get? Okay, this one we need to do some small, calculation, right? So let's use the general rule here. So cot inverse of u is equal to minus 1 divided by 1 plus u squared times u prime. So let's look for our u from this. That is the square root of x. Now we know that square root of x is the same as x to the power 1 over 2. This will help us to look for u prime. So u prime, using the power rule here, is going to give us 1 divided by 2x. Then I subtract 1. So half minus 1 is minus half. I can decide to leave it this way, or those who like doing manipulation can say that, okay, this is the same as 1 over 2 times 1 over x to the power 1 over 2, and this is the same as, this is the same as square root of x. So when I multiply this one together, I'm going to have 1 divided by 2 square root of x. You can also do this, or you can leave your answer here. Simple, no trouble. Unless maybe it is multiple choice and you need to manipulate the solutions to get a specific option. All right, so what are we going to get here? So we have another minus here and we have minus here, so pay attention there. So I need to put this one in parentheses. So minus 1 divided by 1 plus u squared. So u is this square root of x. So I'm going to have square root of x squared times u prime. But if we're using this one, then we are going to have times 1 divided by square root of x. Do some small simplification and let's see what we are going to get. All right. So this is going to give us minus sine of x plus, right? So plus, because when I multiply minus minus, it can plus. Then this is going to be 1 divided by 1 plus. So square root of x squared is going to just give us x times 1 over 2 square root of x. If I want to multiply again, then my final solution should be sine of x plus 1 divided by. So I'm just going to multiply this by that, and I'm going to have 1 plus x. Okay, I can decide to bring 2 square root of x first and then 1 plus x here. Nice. So that will be my solution. So you see that this becomes more easier when I know what I'm doing. Like I know the formulas, I know how to differentiate individual functions. It's more simple for us to work through this. And if you know how to do this simple derivative, knowing how to differentiate functions, then complicated functions are not going to be so difficult for you to, differentiate them. So let's do this one too. The y over the x is equal to me differentiating cot inverse of sine inverse of x. Beautiful. So now what we can do here is, okay, now this we are going to use the change rule. Let me write this one was like, you can see it well. Cot inverse of sine inverse of x. So this is change rule, right? But because the sine is inside the cot, we need to use the general rule that we just learned. So d over dx cot inverse of u minus 1 over 1 plus u squared. So you see, I love writing this. Why? Anytime I'm solving question and I write this general rule down, there's no way I'm going to forget this. There's no way I'm going to make mistake here. So it helps you to avoid mistakes, and it helps you to always, remembering, something like this. You remember that, okay, this is the formula that we are going to use here. So now our u is the sine of x, as you can see. So our u is this from here. So when you look at what is inside the parenthesis, so we need u prime. So u prime is going to give us cos of x. So this is simple, like beautiful. So let's see what we can do here. So this is just minus 1 divided by 1 plus u squared. U is sine, so I can have this all squared times u prime, which is cos of x. We didn't take too much time working on this. So this is just going to give us cos x divided by, so this is the same as minus cos x divided by 1 plus, I can write this one as sine squared of x. Now this, we cannot use trig identity. So if this one was 1 minus sine squared, then we can see that this is the same as cos squared. Then we can cancel so that we get minus 1 over cos. But we cannot use the trig identity for this. Here, so this is what we are going to get for question 3. We are almost done with the practice. Then I'll give you one to also work on it. Let's do this one. dy over dx is equal to d over dx x plus cot inverse of square root of x plus 1. Nice. So this is what we get here. So when I differentiate x, I know we are going to get a big 1. Nice. Plus, now we need to do this. So let's go again with our general rule. So you see that right now I can even do it without using the general rule, right? Because I have been writing it a lot. So I always remember that, okay, this is what we are just going to do. So let's see what we are going to do here. Okay. So I'm going to have this one to be equal to minus 1 over 1 plus u squared times u prime. Beautiful. So what is our u? Okay, let's try and find it. Our u is square root of x plus 1, and this is the same as x plus 1 to the power 1 over 2, so that we can find u prime. Using the power rule and chain rule, 1 over 2 x plus 1 minus 1 over 2 times, and now I need to differentiate what is inside. But the good news is when I differentiate what is inside, I'm going to get 1. So this is just the same as 1 over 2 x plus 1 minus 1 over 2. I can leave it this way if I don't want to do much simplification. But if you want to do simplification here, then this is the same as 1 over 2 times 1 over x plus 1 over 2. And 1 over 2 is the square root, so I'm going to have 1 over 2 times 1 over square root of x plus 1. And finally, we are going to have 1 divided by 2 square root of x plus 1. So we can use this one too as well. So let's come here. So since this is minus, now I change my positive sign to minus 1 divided by 1 plus u squared. What was u? That is the square root of x plus 1. So you see, when you become very good at it and you know the formula in head, like off head, can be just looking at this one and just be writing out the solution nicely. Now u prime is 1 divided by 2 square root of x plus 1. So now if I want to simplify this, 1 minus 1 divided by 1 plus, when I cancel this, this is going to be x plus 1, then times 1 divided by 2 square root of x plus 1. And finally, if I want to do something like more simplification here, I have 1 minus 1 divided by 2 plus x times 1 divided by 2 square root of x plus 1, and 1 minus 1 divided by 2 square root of x plus 1 times 2 plus x. Nice. This is beautiful, right? So this is not difficult to do. So that is basically the idea here. Take your trial question and solve it and leave your final results in the comment section. In the next video, we are going to talk about secant function, how to differentiate the secant inverse. And then we'll look at some examples. And then after we are done, looking at all the inverse functions of trig functions, we take derivatives and we look at other aspects of the functions that we can work with. So see you in the next video.